Hello, for this laboratory report we will first attempt to model a special case of Newton's second law, that special case being where the net force is zero, leading to the situation in which, according to the principle, the initial velocity is the same as the final velocity. In my case, I approximated a model of an object moving at constant velocity by rolling a youth basketball at a medium speed across a level, concrete pad, with the camera placed around the ground about 6 feet away. To create my computational model, I assumed that Fnet was zero, an assumption which will be put to the test when we compare the differences between the observed position and the predicted position. To begin, I analysed my video model using the tracker program. This provided me with the initial values for time t in seconds and the initial location in meters, as well as the final time and position for the object. As you can see, the graph here shows that the movement of the ball is not completely linear, a problem which will be discussed later. Using this formula, I obtained a constant value for my velocity. I then plugged this value into the VPython program. I told the ball to move at this constant velocity while t was less than 1.533, the t final obtained from the tracker analysis. I also changed the opacity of the ball so you can see the movement of the actual centre of mass as opposed to the movement of just a ball. Here is the model playing. The data obtained from the analysis of the movement of the computational model, movement that is unerringly at constant velocity due to the parameters placed upon it. This data was then compared to the data obtained from Tracker in the spreadsheet. You can see the columns for the video model and down here those for the Python model. These two sets of data points were then compared in this graph. As you can see, they obviously don't match perfectly. There are several reasons as to why this might be the case. While these two models obviously line up here at the beginning and at the end, looking back at the tracker model, there appears to be a point in here that becomes less linear. While you can see from the video that the ball started to roll slightly farther away from the camera at the end, this may account somewhat as our decreased perception of the ball's movement. In addition, the net force is not actually zero in real life. The ball naturally began to slow due to its friction with the ground produced by gravity. I think some of the fluctuations in the graph we see here are caused by the moments when the seams of the basketball come in contact with the concrete. The non-perfectly spherical object accelerated the change in velocity. If we were to say that the object was moving along the z-axis instead of the x-axis, the velocity vector would merely look like this with the entries switched to the appropriate positions. If we were to say that the object was moving in the negative x direction, like this, we would merely flip the sign. This can be understood as flipping your paper, a movement which places negative x in the position in which we are used to seeing it. Here we see that the movement is actually in the opposite direction as it would have been. Even though you had to, thank you for watching this video. I appreciate it.